everyone. Good morning. Yeah, so as Eric was saying, I'm Ansgar. I'm a member of the Quilt team. What we do is mostly Ethereum co-development, so it's a little bit of a collaboration between Consensus and the Ethereum Foundation. And this is the talk that I'm going to give, and I wanted to start by just giving a little bit of like a motivation for why these two somewhat separate topics. And so this EIP-3074 that I want to talk about, this is just the header of the EIP. As you can see, it's basically an EIP that the team and I, we basically created roughly 1.5 years ago already. And since then, we've been giving a lot of talks about it, just basically trying to create some momentum for it, educate people, and all these kind of things. But more recently, people have been coming up to us and have been asking things like, will the EIP ever reach the Ethereum mainnet, right? We've been talking about it for over a year now. Can we expect this to have actually become reality? And then also, and that was what really kind of was the most interesting question to me, like in the last few months, people have started also asking, could it maybe be introduced to one of these rollups first and then maybe later on come to Ethereum itself? And that got me thinking, and so instead of just repeating the same talk that I've been giving for a year now, I wanted to basically split up the talk a little bit, and I will still talk first about the EIP. So if you have never heard of it before, don't worry, like I'll explain it. But then in the second part of the talk, I also want to talk a little bit, like zoom out a bit and give some context and talk about why is Ethereum moving to rollups again, and what are the implications, and what does it mean for things like this EIP and for the governance of the EVM in general. So yeah, that's the plan. So let's start with the EIP itself. So basically, the one-line summary that I would give is that with this EIP, we are trying to allow EOAs. EOAs is just accounts that have a private key, so like your MetaMask accounts are all EOAs, to operate like smart contract wallets. So you might have heard of Gnosis Safe or these kind of things, and these smart contract wallets really have a lot of really nice advanced features. And basically the idea was, how can we bring at least some of these features to these accounts as well. And specifically we want to address a couple UX problems. So if you've ever interacted with anything really DeFi related, you're probably very familiar with this flow where you first have to send an approval transaction and then you send a separate transaction to actually do the thing you wanted to do. And sometimes that might even be 3, 4, 5 separate transactions you have to send. And more generally, basically actions on Ethereum tend to be like really, why is there no? Ah, okay, I pressed the wrong button. No, I think it might be internet latency, whatever. So, and more generally, basically, actions on Ethereum tend to be one-to-one correlated with transactions underlying. And to some extent, that's just a problem with contract design, but it is also in like a insignificant part just a consequence of how the EVM is designed today. I hope that this doesn't keep happening. Let's see. Okay, anyway, so some other UX problems we wanted to address are that today there is not really good defense against losing access to your EOA, right? If you lose your seed phrase and then your device gets stolen or whatever, you might not be able to recover your EOA, or you won't be able to recover your EOA. And then also, wow. But right now, you basically always need Ether, and that's really not great for onboarding new users. So that's just like a mixture of different things that we all wanted to address, and by making EOAs basically more powerful. And the root problem, and this might be a bit technical, but if you've ever like looked at a smart contract, you might be familiar with this, is that the way contracts usually authenticate the user interacting with it is just by looking at this message.sender value. To explain that a little bit, so here's, just like to give an example, this is the ERC20 standard transfer function, and in there you can see that just to determine which account actually sent the transfer, so which account do I take the balance out of, the contract just looks at this message.sender value. And more generally, basically whenever you have some sort of smart contract interaction, so you see like the transaction starts at this gray box and then it calls into a contract and then calls into another contract and all these things. So at every step, the message sender is basically set to the to the entity calling it. And if you look here, only in the very first step is the message sender actually the account controlled by the user, right? And so only in the very first step can you do something like send tokens or approve them or all these kind of things. So basically, whenever you have to do, there are multiple things you want to do from your account, you basically have to create a new transaction every single time. So how do we fix this? There have been a couple solutions in the past. The first one that you might have heard of were meta-transactions. Meta-transactions basically is the idea of doing like indirect transaction routing where the user basically signs the action instead of directly sending a transaction, and then the contracts they interact with know how to handle these signatures. And as you can see already, this is going to be a little bit of a meme. I've stolen that from my colleague who's been giving this presentation a lot. And so this is like the implementation. You can already see it adds a lot of complexity. That's basically the equivalent of a transfer just in this meta-transaction style. And then the question is, do they actually solve the problem? And the answer is unfortunately not really. I'm a big fan of the idea of meta-transactions, but the problem is that every contract has to explicitly add support for them, and a lot of contracts don't, and so there's not a lot of interest in building up good tooling for it because most contracts don't support it, and because there's not good tooling, most contract developers don't bother integrating with it. So it's basically like this vicious cycle where it was a really nice attempt, I think, at solving this problem, but it basically got stuck and didn't really go anywhere. Then the other approach, and that's basically coming right from the motivation of making EOAs more like smart contract wallets, why not just use smart contract wallets directly, right? Smart contract wallet solves this. The problem here is that while that's true, smart contract wallets are also really, really expensive, right? So basically, whenever you want to deploy a Nose Safe, that's easily like $100, and then every time you use the wallet, it's much more expensive than just sending a normal transaction. So it's just really, it's a great solution, but just not feasible for most users, right? And also, and that's a little bit of a teaser for the next talk, so stick around, but right now at least, smart contract wallets can't directly initiate transactions, so you always have to go through some other account first. So then, if all of these solutions don't like fully address the problem, how do we want to address the problem? Well, that's where the EIP comes in, EIP-3074. And the important thing here is that like we don't only want to solve these problems, we want to solve it just for free, just adding features to the existing accounts that all users already have and mostly love, or at least tolerate, I don't know. So how do we do this? Well, we do this by introducing these two new opcodes, these two new basically elemental operating steps to the Ethereum Virtual Machine. And basically, conceptually, don't bother reading all the details unless you're one of these people interested in all that stuff. But the conceptually, basically, the idea is the user basically signs over an action they want to perform, or multiple actions, right? Like if they want to perform 5 actions or whatnot, or sign over whatever other things they want to allow their account to be used for. So that could also be something for social recovery. They could sign over this other person is allowed to send in my name, right? So all these kind of things, you can just put that into a signature, and then a contract on Ethereum can use this magic auth functionality to verify that signature and then basically gain the right to impersonate your account and send transactions in your name. And then they can use this auth call function to send like basically like a sub transaction, but they can importantly just use that like 5 times in a row, right? To do 5 different things all within one transaction. So this is kind of the underlying magic that would make this EIP work. And just to look at how this actually looks like, right? So the user, again, is signing the message for whatever kind of use case they have in mind. The contract verifies that with the auth, and then it's actually executed, right? And this contract that does these things, that would be like a special type of contract. You can think of it somewhat similar to like your Nose Safe today, right? And we are calling these contracts the invoker contract because they invoke these special opcodes. Importantly, basically, as I was saying, when you sign a message, you only want to allow the contract to do specific things, right? You don't want a contract to just take all your NFTs and run with them, right? You only want it to do whatever you authorized it to do. And the invoker here has the special role of actually enforcing these rules. And that's somewhat of like a problematic security implication as well that we'll talk about in a second. But just to look at how that works in practice. So say this would be like one of these messages you sign, and importantly, you basically the type byte doesn't really matter. The invoker address, so that's basically you're only granting access to your account to this one specific contract, and that contract could be a invoker that's specialized for bundling transaction, or it could be some like a contract for key recovery, or for whatever type of interaction you want to use, basically. And then in the commit, that's basically where you tell this invoker contract what you intend the authorization to be used for. And so in the commit, you could put like a hash that references a transaction, right? Like a nonce to gas call data, and then it would take that and it would actually perform that action. Or you could, in case of like a bundling version, you could put multiple transactions in there, right? So basically, the commit is your way of communicating with the invoker and basically telling it what it is supposed to do with your authorization. But importantly, with the authorization, you technically give full control over your account to the smart contract. But because it's a smart contract, there's no one can manipulate it or anything. You can read it in advance. You can see what it's able to do with your signature. So this is kind of the EIP at a glance. So what's the status of it? Why isn't it on Ethereum yet? Well, for that, to understand that, we have to kind of talk now a little bit about like how do things actually get onto Ethereum? How are they included in practice? And so just to basically give that some context, so the timeline here, we created the EIP in October of 2020. We then picked the first hard fork that we hoped the EIP could be included in. That was the London hard fork last year. So in March, we proposed the EIP for London. Technically, there was this Berlin hard fork before that, but there was way too short notice, basically. So we didn't try to get in there. But then people had some security issues, so we also commissioned some audit reports that came back very positive for the EIP. But then, unfortunately, August came along and people decided London EIP-3074, that is like already a big change. We just don't have room for non-topical EIPs. So the EIP was not included after all. Then in September, we were like, okay, no big deal. We'll just give it a new try. So the next hard fork that will have room for EIPs again will be Shanghai. So let's just propose it again for Shanghai. Shanghai will be the hard fork after the merge. But then, unfortunately, now basically people looked into what do we want to do for Shanghai. It turned out there was already a long list of other EIPs. A lot of them are really important. For example, beacon chain withdrawals, right? If you're running validators, you want to be able to, if you for some reason want to stop validating, you want to be able to withdraw your ETH out of the beacon chain. So that was important features. There were a bunch of other really important ones all lined up. And so people again said basically there's no room. And so at the earliest Q4 of this year, maybe a little bit later, we'll have this next hard fork, and again, the EIP will not be in there, right? And you can already see it's basically just one opportunity a year. If you miss it, you're kind of out of luck. But then also, maybe to take a little bit of a closer look at what's actually happening in the governance process. Actually, the governance process consists of two different steps. So the first part is the EIP process, where you basically just make sure that the proposal you have, the idea you have for changing the virtual machine or changing whatever part of the protocol you can think of, that it's well specified, right? So you create one of these EIPs, you follow the rules that are outlined in this EIP1, which is basically like explaining what exactly you have to do, and then the EIP process just makes sure that your proposal is well specified, right? That people could just take it and implement it if they wanted to, and that there are no open questions, no things you might have forgotten about, these kind of things. But there's no judgment yet in that step of the process, right? Or if like whether it makes sense to do that or not, that's just a formal step. And then the second part, and that's I think where it's really interesting, that's the core developer process, and that's where actually all the decisions are made. So this is just a screenshot from the bi-weekly core dev calls. I can very much recommend, like before I actually became like a core developer myself, I basically watched every single one of these for several years. they're really interesting, but that's basically where all the client developers, researchers like our team, all people basically involved with the base layer come together and look at, okay, there's a new fork coming up, what EIPs basically are there that we could include, and do we want to include them? And for that, basically, there's this list of criteria that it's a bit of an informal list. I tried to just formulate it here, but the idea is basically a proposed change has to be worth it, right? It has to be valuable, and importantly, it has to be valuable enough to justify adding complexity to Ethereum, right? The second question then is the change safe? There's basically like a very uncompromising spirit to this step, where if there's any question about whether something could potentially break Ethereum, we will not do it. So this is like a very important requirement. And then the third one, though, and that's actually where most of the EIP end up stalling. This is like, do we actually have the required attention to go through the EIP, right? And the attention, that's actually quite a bit of commitment. So that's, you need to review the EIP, make sure that there are no edge cases left out. You have to implement the EIP, you have to do all the testing. So this is really where most of the work is, right? And so then thinking about our EIP, right? First, maybe just let me briefly shout out if you're at all interested in this code of process, but you might not want to actually watch all these calls because they can be a little bit technical. I very much recommend following Tim Baker on Twitter. He's the guy in charge of the calls, and he has these amazing summaries every time after the call. So do give him a follow if you don't already. But like now let's come back to our EIP. So how did it play out in the governance process? So first off, we were on a lot of calls. So this is just like a list of all the calls that we were on the agenda for. We weren't actually like present, like it wasn't discussed on every one of those, but on the majority. So there was a lot of discussion about it. And then the verdict was basically, generally it would be valuable, right? It's an amazing EIP. I mean, that's my possibly biased take, but it's a nice EIP. Let's put it that way. A lot of users really like it. It would be very nice, but importantly, people had security concerns, right? As I was saying, with the invoker contract, it can basically take full control over your EOA, and then there's this commit functionality to limit it. And we spend a lot of time making sure that actually we think it's safe. But the problem is, we spent all that time. The rest of the core developers didn't spend the time yet, right? So they trust us that it's safe, and that's of course not enough, right? They have to actually work through all these ideas themselves, and there's just not enough time for that yet, right? And so basically, what we're right now, the situation is that we're in is basically we're waiting that there's enough of a gap in Ethereum progress that people just have the free time to go look at our EIP and really talk with us about exactly why is it safe and why basically can we bring it to Ethereum without breaking everything. That's kind of the position we're in. And also there were some other smaller concerns, but I think we were more confident being able to address those quickly. So that's basically a little bit of an overview of where this is basically at in the governance process, and then to now briefly go to the second part and talk a little bit about what about rollups? Can they maybe help? So I'll have to glance over some of the details that also, like I think Proto already talked about very well in his talk just now. But basically, why did we choose a rollup-centric roadmap in the first place? So basically the idea was the early insight, like a monolithic blockchain just doesn't scale, right? You can't have every person in the entire world validate every single transaction. So we came up with this idea, like people in the very early days of Ethereum came up with the idea of like, let's find a way of splitting up the activity on the chain so that everyone only has to look at the parts that they're interested in. And so the first approach that people went with was just to say, how about we take 1,000 copies of Ethereum and we just call them shards, and they all run in parallel, and that way we get some scaling. Then after that, people were like, yeah, but if we are already creating new chains, why not improve them? Why just copy them? We could make them better. We could have these EOAs, Ethereum WebAssembly. We could have execution environments that basically the idea was to make them more kind of customizable. Again, this is not all that important. The takeaway here is just that all this approach was just not efficient enough, right? So basically, people wanted to add more and more functionality, but we needed a way to basically to make this really efficient. And this is basically where rollups came in. So rollups, how do they work? Well, they basically have a long history of other layer 2 research before that. If you were around in the days of Plasma, you might still be traumatized from how we spent years in that direction, but oh well. The key idea that we then finally had with rollups was we can separately treat the problems of scaling the execution and scaling the data of a chain. And if you do that, basically, the idea is that for execution, we actually came up with these marvelous techniques of using fraud or validity proofs, like validity ZK proofs, to compress what the base chain has to do to like a very, very minimal amount. So execution was all of a sudden basically solved. And so the only thing, I mean solved, but at least deferred to the layer 2 teams to figure out. Let's put it this way. And Proto is smiling very brightly right now. So this is very much not a solved problem, but at least now basically we have a lot of teams looking at this separately. And then for data, this is basically now what the scaling effort on Ethereum really came down to. How do we scale data on Ethereum, right? And we have all these ideas of how we can actually do this. And this is literally basically now what we can focus on. So how did this play into our sharding design? First, we just basically realized we don't need that many shards, and maybe some of them we only need for data. Then we looked at the existing Ethereum chain, and we were like, yeah, but we already have an Ethereum chain, so why don't we just use that as the execution chain? Why do we even have to create all these new execution chains at all? So this is kind of where the merge idea came from. And then most recently, people looked at the data part of the equation and were like, why do we even need sharding at all for data scaling? Can't we do more efficient ways? And this is where, if you've heard this on Twitter recently, this new approach, dunk sharding, comes from that makes sharding really efficient, basically. And just as a quick aside, I think we should stop calling it sharding. It's really sharding in name only. We now do this more efficient way of data scaling. We should find a better name. But yeah, I assume that's probably like a lost cause. But I wanted to put it out there anyway. So what's the transition plan here? Of course, next up is the merge. That's just like a preparatory step in terms of scaling. Of course, there's a lot of other nice benefits. Then, as I was saying, at the earliest, at the end of the year, we'll have the Shanghai fork. Ideally, there's this effort of the EIP that Proto talked about, this proto-dunk sharding, basically the 4844, that would already give us a lot of the benefits of sharding, just not the full throughput yet. And then we have this fallback EIP that like Vitalik and I proposed last year that would just make the existing data type, the call data, cheaper. So in case the other one turns out to be too ambitious for that timeline, we have the fallback plan. And then after that is done next year, hopefully, or whenever we are ready, we'll do the full sharding, and then basically data will be endless and everything will be beautiful. So this is kind of the plan. And so let me take the last 2-3 minutes that I have and just talk about the implications, and then come back to EIP-3074 and how that ties in. So first off, I think this is like, you might have heard this term thrown around, like the modular blockchain, right? And I think this is really one of the key advantages of this rollup-centric approach, that it's important, I think, for people to fully internalize, right? With this move to rollups, we basically unopinionated on how to scale Ethereum, right? We only provide the tools, and then all these rollup projects can choose what to do. And I don't want to go through this entire list, but there's a billion different choices that rollups can make that will lead to really, really interesting different trade-offs and alternatives in the scaling space. And in that way, basically, we are replicating all the benefits that we get with layer 1 diversity today, but we now all get that on top of Ethereum, so you have the same shared security, the same native interoperability, and the same currency on all of them. So this is really, I think, this slide is basically, I think, what rollups are all about in terms of the value they create. But in terms of the implications, and I think this is something that people haven't really talked about much, so this is mostly just like a list of open questions, but Ethereum was really designed to be a user-facing platform first, right? Like the EVM, Solidity clients, tooling, all of these kind of features. And now, all of a sudden, it's mostly a rollup management layer, right? So what exactly does that mean? What will the implications be? Will it continue to be like, will layer 2s copy some of these tools? Will they do their own thing? It's I think, very much an open question for now. And specifically, there are like a lot of open questions for the clients, for Solidity, for research. Like, how does this new world work? Where basically users don't just use Ethereum themselves, but they use the rollups. And then on the VM, and that's kind of where we're tied back to the EIP-3074. Basically, the question is, how will rollups treat the EVM? Will they just copy it, or will they modify it? And if they modify it, how will we achieve standardization, right? Or do you basically have to install separate MetaMask and separate tools for every single rollup you use? And then if they end up using the same virtual machine, right? How does it work with the governance process? Right now, the governance process, that's only layer 1 teams coming together deciding about new features. But how do we basically integrate layer 2 teams into this process, right? And so, again, there are no answers yet. But just to leave you basically with like looking at the 2 questions we started with, will the EIP ever reach Ethereum mainnet? I think, hopefully, but we will have to see. And then could it be introduced first to some of the rollups? And there, I think, basically, my motivation was just to give you a bit of a framework how to think about this, right? So I think in order to answer this, we first have to just figure out how will virtual machines in rollups even look like, and what's the path to be taken there. And this is basically what I wanted to get across. And with that, thanks. And if you want to find the slides, you can find me on Twitter. And I think, unfortunately, I don't have time for questions, so do find me after the talk outside. I think there's a break now anyway. But
yeah, we do have a break, and that's fine if you don't have time for questions. I was just going to say that my boss, Dan Finlay, this is one of his favorite EIPs, so just wanted to throw that out there. And I have him on Slack saying so.
Nice. Yeah.
I did have a quick question. So you can have a contract between wallet A and wallet B and enable like delegation and key rotation?
Wait, can you repeat that?
Like you have a wallet A and a wallet B, and the contract could be enable like delegation and key rotation? Right.
Yeah, I think that would be one of these examples. So basically, you can give control over your account to a different account that would then basically you're delegating, and then you can at any time revoke that control, right? So the nice thing is, because these invoker contracts are full smart contracts, it's no longer just an ECDSA signature. You can program in whatever functionality you'd like. So this would actually be an amazing use case that I never thought about before. And this is the point, right? We don't want to be opinionated. We want to give you tools, and then you build all the use cases you could think of.
I was going to preface that with, this is a silly question, but thank you.
No, it's
all right.
Amazing.
Well, everyone give it up for Ansgar Dietrichs. And yes, we do have